All right. Yesterday, we learned about circular motion and the difference between linear speed and angular speed. And one thing you want to keep in mind is speed is referring to how quickly something changes over time. So when we look at angular speed, we're looking at how quickly the turning happens over time. So that's where you're taking just the measurement of the angle and dividing it by how much time passed while it made that turn. Linear speed, however, is looking at the actual arc length, how much arc length has occurred with respect to time. So you want actually the arc length, which is represented by the letter S. And let me go back. Okay. And we found out that the formula for arc length, which again is represented by the letter S, is the radius multiplied by the angle in terms of radians. So if linear speed is the arc length divided by time, and arc length is the radius multiplied to the angle, then when I put together the fact that angular speed is the angle length divided by time, I can then realize that linear speed is angular speed multiplied by the radius of the circle, which we see right here. So these three are a very important set of formulas. And hopefully from yesterday, you understand the difference between angular speed and linear speed. Angular speed is just how quickly it turns. And we're used to that when we talk about things like RPMs, because RPMs is revolutions per minute. Angular speed is just how much turning, how many rotations with respect to time. Linear speed, though, is basically like rolling out the circumference. So let me show you again. Why can't I get this to go away? I want it to go away. Can't get it to go away. Never mind. But let me see if I can find that because it disappeared on me now. I can't find it. Okay, I'm going to let that one go. Anyway, so angular speed, linear speed. Come on. It's not moving. Okay. You just don't want to listen to me right now, computer. I've been having serious lag time issues today, and it's very, very frustrating. Okay. So, again, as I was saying, a very common unit of angular speed is RPMs, revolutions per minute. And one thing to keep in mind is if you know how many revolutions you have per unit of time, if you know your RPMs, and you want to know your angular speed, the angular speed is taking the number of revolutions per minute or per unit of time and multiplying by the circumference of a unit circle, 2 pi, or how long it takes to make one full round. Now, we are going to do, whoopsies, that's the answers. We are going to do example 1, and we're going to think about this logically. Where is example 1? Oh, sorry. Never mind. Okay. You have a bicycle wheel. It is spinning at 100 revolutions per minute. You want to know the angular speed. 100 revolutions per minute is already a speed. How many radians are there in one revolution? So I'm going to check my chat. How many radians are there per one revolution? 2 2 Okay, come on. Thank you. 2 pi. 2 pi. So what I want to do is I want to multiply my revolutions per minute by how many radians there are per one revolution, which is the formula I was just talking about a moment ago. So does it make sense that if you want to know your angular speed based on revolutions per minute, that you need to take your revolutions per minute and multiply it by 2 pi? Does that make sense? I hope. It's hard to get a response out of you. So 100 times 2 pi, and then we can write that as a decimal number if we want. I'm going to leave it there. I'm also going to say that that is equal to omega. It looks like a W, but it's the Greek letter. And I just want to point out to you that I'm using the standard letters. Oh, wait, I wanted to go here. I'm using the standard letters that you will typically see in textbooks. So omega right here, that's what I'm referring to. Omega is representing the angular speed, and V is going to represent the linear speed when I write the letter V. So we've got a lot of formulas right here to use. Now, realize that I know my angular speed. Now this is asking, what is the linear speed if the wheel of this bicycle has a 24-inch diameter? Now let's remember, what is linear speed? Linear speed, which I just showed you, we'll use the letter V. Linear speed is equal to the radius of the circle multiplied by the angular speed. What is the radius of the wheel with a 24-inch diameter? Hmm? 12. So the radius is 12 if it has a 24-inch diameter. And the angular speed was found in the previous part, and that gives me a total of 2400 times pi, which you can leave as 2400 pi, or you can find the decimal equivalent, whichever. So that's the answer to part B. Now, realize that what we just found was linear speed. That's like finding how fast your car is moving. If you want to know how far this bike travels in 1 hour, you want to first realize What are the units of this excuse me, linear speed? We need to go back to the beginning. In the very beginning, the time unit that we were using was that we had revolutions per minute. Then I took the revolutions out of the picture and got radians per minute. I took radians per minute and I multiplied it by the radius. What are the units of this radius? What are the units of the radius? Inches. Now, I was trying to explain to you a little bit yesterday that angle measurement, radians, technically isn't, it's a dimensionless unit. It's more of a placeholder. So when I write my linear speed, I'm actually using inches per minute, not inches times radians per minute. Now that I've got the units straight, if I'm traveling at this number, the speed in inches per minute, and I want to know how far I travel in 1 hour, what should I do? Just logically think about it. I want to know my distance. Come on. And distance is equal to speed times time. My speed is 2400 pi inches per minute. I need to then multiply that by my time. Now my time is 1 hour. But what do I need to do before I actually multiply these numbers together? I need to look carefully at these units. My speed is in inches per minute. My time was given as an hour. Minutes and hours are not the same unit, but what is the conversion? And I'm trying to see. I'm trying to. Okay, there we go. Yes, convert hours to minutes. I was trying to read my chat and I was just having difficulties with my computer. So, convert hours to minutes. What should I do? Unplugging it. There you go. There are 1 hour is equivalent to 60 minutes. And now I can multiply those two numbers together to get an answer for how far the bike traveled in 1 hour. And go ahead and multiply the pi in there. Do you guys have your calculators? What is 2400 times pi times 60? Answer key 4. Okay, let me check my answer key and see if I messed up somewhere. I don't have the pi written in there. That might be the issue, is that a difference between having my answers in terms of pi versus decimal numbers. So let me change these numbers. So I'm going to start with the answer to part A is 200 pi. And I'm going to double check with my answers. 200 pi is 628.3. Yeah. Yeah, it's just a difference of I incorporated the pi in the answers here because it makes more logical sense if you have decimal numbers. Then for part B, I had 2400 times pi. 2400 times pi should be 7539. And there we go. Then for part C, I am trying to multiply 2400 times pi times 60. And that gives me a long number. Yes. Or hold on. Yes, right there. Let me highlight so you know what I'm pointing to. Now, part D, another bicycle has wheels with a diameter of 29 inches. How far will that bicycle travel in 1 hour? So with problem D, I'm trying to get you to think through the process that we just used. And I want to remind you that we began with revolutions per minute right here. To get angular speed, we multiplied revolutions per minute by how many radians it takes to go around a circle. And that gave me an angular speed of 628.32 radians per minute. Then I multiplied the angular speed and the radius, which was in terms of inches, and that got me that the speed of the bicycle is 7,539 inches per minute. When I wanted to know how far I traveled in 1 hour, I took the speed and I multiplied it by time, realizing that I needed to use the same time measurement. So 1 hour was 60 minutes. Coming back over here, do you think you can figure out part D? And I should point out this is assuming that we are keeping the same angular speed. And I want to write that as a decimal. 200 pi 628.32. To go from angular speed to linear speed, I multiply the angular speed by the radius. If the diameter is 29 inches, then the radius is 29 halves. And let's multiply that together. Are you guys using your calculators? Make sure you do this with me. That way it makes sense when you work on it with your homework. My linear speed is 9110.64. And then I want to make sure I use the right units. Inches per unit of time, which is minutes. Once I know my speed, which is the linear speed, to find distance, I'm always looking at speed multiplied by time. I just got that my speed was 9,110.64 inches per minute. I need to multiply that by the amount of minutes. 1 hour is 60 minutes. And then when I multiply those two numbers, that's going to tell me how many inches were traveled in 1 hour. And I went ahead and just wrote in parentheses after the answer in inches how many miles we were talking about. I just used the conversion from inches to miles to get that, just to kind of put that out there. So what I also want you to realize is the bicycle with the 24-inch diameter versus the bicycle with the 29-inch diameter. Look at the difference in the distance they were able to travel with the same exact angular speed. And that's the value of having larger wheels. Then I believe I went over example 2 with you yesterday. Yeah. With number 2, I took you through using the formulas. Shouldn't you multiply by pi at the end? So it's most. Yeah, you can. Multiplying by pi at the very end does keep it as the most precise. Okay, what was my note there? I think I went over that yesterday. So let's move on to example 3. That's where we're at. Okay. We'll do examples 3 and 4, and that will round up classwork 7.2. I want to give you a moment to read it, think about it. You've got logic as well as formulas. An object travels a certain distance, 35 feet, in 2.7 seconds as it moves along a circle of radius 2 feet. I'm having so much trouble getting my pen to obey. So we've got a point moving along a circle. We know that the linear distance is 35 feet. If I take the linear distance and divide it by the amount of time that it took to go that linear distance, what will that give me? Oh, you made a mistake on the classwork question 4. Did I? I'll look at it in a moment. So I want to make sure that this is making sense to you. I am doing distance divided by time, and it's linear distance divided by time. What is that going to give me? Distance divided by time is what thing? And, oh, you're giving me the number answer. So I'm getting 12.96 feet per second. But what is that telling me? It is telling me the linear speed. Nayum? I don't know. The problem wanted me to find the linear speed and the angular speed. Now that I have the linear speed, there's an easy way to go from that to angular speed. Because linear speed, which I was using a v to represent, is equal to the radius of the circle multiplied to the angular speed, omega. I know the linear speed is 12.96. The radius of the circle is 2 feet, and I need to find the angular speed. So I need to divide by 2. Yep. And that will give me my angular speed. And where was that? There we are. And there we go. There's 3. I was on the wrong problem. Okay, feeling good about example 3. I want you to make sure you read over it and that it makes sense to you. Not just that the formulas make sense, but this is showing you an application of math. Now let's move on to example 4. After example 4, we'll be ready to move on to the next classwork. Okay. An object moves at a constant linear speed of 10 meters per second around a circle of radius 4 meters. It helps to just write down the information that you have. I have my linear speed, and I'm using v to represent linear speed, 10 meters per second. I have the radius of my circle, 4 meters. I want to know how large of a central angle do you need to sweep out? How much angular motion takes place if it goes through, what am I saying? I need to read the whole thing again. An object moves at a constant linear speed of 10 meters per second around a circle of radius 4 meters. And I want to know the angle that it goes through over a time of 3.1 seconds. Hold on. Now I have a variety of formulas to choose from. So these formulas that I gave you right here are very, very, very important. Out of these formulas, what's going to help us out? And so the formula of linear speed is the radius times the angle that is swept out divided by time. If I use that formula on the information that I have, oh my God, it keeps changing my place. And I don't know why it keeps doing that. Then I can plug this information into that formula. So I'm going to take 10, multiply it by 3.1. That'll give me 31. And then divide it by 4, and I'll have my theta. Okay. So for your homework assignment on 7.2, that is due today. And I had gone over some of this with you yesterday. So you're going to need to make sure that you can find the arc length using the formula that arc length is radius times theta. And then you have 2, 3, and 4 are both questions that are application problems. Okay, I'm going to